In this lesson, we're going to create a DIP 16. It's a through-hole device, and we're going to be using the pad stacks that we created. This is a picture of the device actually mounted into the circuit board. You can see that the pins are going into the holes. They're getting soldered. The green, of course, is your solder mask, preventing you from getting any solder from a pin to a trace, for instance. This little marker denotes that pin 1 is on the left side of this component, which would be right here. Sometimes they actually have a little marker here. Pin 1 is usually denoted with a square pad. So this particular company decided not to do that. Now this is the dimensions of the component. This is what you'll be using to create the component. The company you work for will probably give you something like this. It'll give you your pin-to-pin distance, and it'll also give you the span. It'll give you the dimensions of your actual part and anything that you need to create the part. So we're going to open up our Allegro editor, and it's going to be a file and new. It's going to ask you what it's going to be, and this is going to be a package symbol, and we're going to use the wizard. It's going to make our job a lot easier. And we're going to be also creating it manually later on. But for now, let's try the package symbol wizard. Say OK. Oh, and I didn't specify a file. So we're going to go DIP 16. 16 pin DIP. OK. And we see that it's already got the correct dip in it. We say next. Also, I should mention this wizard allows you to do SOICs, PLCCs, SIPs, ZIPs, pretty much anything you need. But complicated parts, you'll have to make them manually. And we are going to use the default Cadence supplied template. We're going to load the template, and then we're going to say next, and everything is mils. I'm going to say let's do accuracy 1. Reference designator will be a U, which is our standard reference designator for a part like this. And let's go to next, and the number of pins is 16. And the lead pitch is 100. And if we go to this, just to show you, this is the pitch. If you notice, it says 100. 0.1. We're in mils, so 1,000 mils equals an inch, so 0.1 inches is 100 mils. Also, we'll see that the body is 265. You always use the highest number. It's always good to go a little more than a little less. And the length of it is going to be 790. So that's this number here. Again, always use the biggest number. Okay, so I'm going to fill 265 in here. And 790 in here, and all the numbers we need are correctly put in, so we say next. The next thing that pops up is the default pad stack to use for the simple pins. If we go to our package dimensions, we see that the thickness, or the dimension for the pin, is 0.22, which is 22 mils. We're going to be adding, another at least 10 to this, which would be 32, and we have our a nominal pad stack of 6038, which would be close enough for this, and we can use that, which is as a pretty much of a standard pin for this device. So what we do is we click on this little icon here, and we search our library, which I think is right about here. So the default would be a 60C38D, and we say OK. And the pad stack for pin 1 is the same pad stack, except we'll put a square pad, which would be, let's see if we have one, 60S38D right there. Say OK. And then we go to next. The next thing the wizard is going to ask you is the location of the symbol origin. On DIPS we always have pin 1 as the symbol origin. And we are going to create a compiled symbol, and we're going to say next. And it says press finish button to create and load the package symbol in your editor, so we say finish. And here is our finished symbol. Notice that pin 1 has a square pad, and we have 16 pins in there. And if we want to measure, if you go up to your little icons over here, you see this little 1, 2, 3 measuring stick, and that puts you into the measure command. If you go to find, if you want to measure pins, for instance, or C-lines or lines, all of this can be put on or off. In this case, we'll just keep them all on. So if we measure from here to here, we're going to see that we have 300 mils, which is what we wanted. If we measure from here to here, we see that we have 100 mils, which is correct. So if we want to measure the body, for instance, from here to here, now these are considered other segments. So if we click on it, we see that it is highlighted. We click on this one, we see that's highlighted, and it gives you the dy as 790, which is the up and down distance. Y is distance from here to here. X is distance from here to here. And if we clicked on this one and this one, that'll give you the dx, which is the side-to-side distance, which is 265. So it looks like everything is good, and we're going to move on to the next lesson.